Welcome back, students. In today's class, I will tell you the difference between sigma and pi bond. It is because these type of bonds we are going to use in second type of hybridization. So we'll see what are sigma and pi bonds. I'm writing over here that is sigma and pi. Sigma and pi bond. I'll give you some examples for that. Suppose this is the internuclear axis. And by default, we consider z-axis as internuclear axis. So this is the axis that combines the nucleus of two combining atoms. Now here, suppose I have a hydrogen atom. This is s orbital of a hydrogen atom. Now here is another nucleus of another hydrogen atom, and this is the s orbital of that hydrogen atom. Now they are overlapping with each other and they are forming this bond. Here you will see that the bond is also on internuclear axis. This bond is formed by the head-to-head overlapping or head-on overlapping of two s orbitals, that is leading to the formation of bond on internuclear axis. Likewise, this is say H2 molecule, hydrogen molecule. Now again, this is the z-axis. Here I have a hydrogen atom and this is the s orbital of hydrogen atom. The second I have is a p orbital of say chlorine. They are overlapping with each other to form this bond. So this is between S and P. The molecule is HCl. In both these bonds, you will see a common thing is that the bond is formed by head-to-head overlapping or head-on overlapping of two atomic orbitals. It is formed between SS and SP. Next, I will show you that is between P and P. Likewise, we can have another example like that of O2. So here in this case, I'll show you another example that not of O2, in fact O2 will take in pi bonds. I'll show you another example that is of Cl2. So suppose here again, this is the z-axis. This is the p orbital of one of the chlorine atom. This here again is a p orbital of another chlorine atom and they are overlapping head-on to form a bond. So here you will see that the bond is formed between P and P, that is Cl and Cl. So this is Cl2 molecule. So we saw what is common in sigma bond. In all these sigma bonds, you have seen that the bond is formed on internuclear axis, on axis which is joining the two nucleuses of two different atoms. Sigma bond can be formed between SS, SP and PP orbitals. Now we'll see a pi bond. What is a pi bond? Let us have a look at that. I'm giving you an example of a molecule like O2. For suppose I'm talking about electronic configuration of oxygen that has got 2 electrons in the S and has got 4 electrons in the P. That is 1, 2, 3 and 4. You will see 2 unpaired electron in P. I can write them as X, Y and Z. Now again I am drawing the z-axis. Suppose this is the z-axis. This is the pz of one of the oxygen atom. Then I have pz of another oxygen atom. They are overlapping head-on to form a sigma bond. But if we have a look at the y-axis, suppose this is the y-axis. If we have a look at this y-axis, the y-axis of both the oxygens, they have got unpaired electron. So on this YP orbital, PY, you'll have unpaired electron. And these P orbital on y-axis, they will overlap sideways to form a pi bond. That means if we have a look at oxygen molecule, suppose this is one of the P, the second P is like this. Say this is the internuclear axis Z. So a sigma bond is formed on internuclear axis, which you can see here. This is the sigma bond which is formed. The two p orbitals are overlapping sideways to form a pi bond. So by sideways overlapping, you'll always have a pi bond. So between two oxygen atoms, you got a sigma and a pi. That means oxygen molecule has got oxygen double bond oxygen. One of the bond is sigma, while the another one is pi, which is formed by sideways overlapping. So sigma bond is formed by head-to-head overlapping, head-on overlapping, whereas pi bond is formed by sideways overlapping. So we'll see some differences between them. I'll write down differences because many a time these differences they are asked in the exam. What are the differences? Or write down at least two differences between sigma and pi bond. First is sigma bond is formed by head-on overlapping of two atomic orbitals. Pi bond is formed by sideways overlapping of two atomic orbitals. Sigma bond is always formed on internuclear axis, that is the Z axis, which combines the nucleus of the two combining atoms. Pi bond is always formed on any axis perpendicular to internuclear axis. Perpendicular to internuclear axis. In sigma bond, the extent of overlapping is larger. So, due to larger overlapping, sigma bond is stronger due to lesser overlapping. Pi bond is weaker. Next, sigma bond can be formed between SS, SP and PP orbitals. Or orbitals, whereas if we talk about pi bond, can be formed between PP and PD orbital. So sigma bond can be formed between SS, SP and PP orbital, whereas pi bond is formed between PP and PD orbital. Never you will see S subshell is involved in pi bonding because S subshell cannot overlap sideways. It always overlaps head on. So S will never form a pi bond. So this is the basic difference between sigma and pi. Again, a recap of this. Suppose two hydrogen atoms, they are overlapping, their s orbital will overlap with each other. The bond formed will be on internuclear axis. That is a sigma bond. So sigma bond can be formed between SS. Likewise, in HCl molecule, s orbital of H will overlap head-on with Cl, with p orbital of Cl, leading to the formation of a sigma bond that again will be on the internuclear axis. Likewise, in Cl2 molecule, the p orbital of 2-chlorine will overlap head-on, leading to the formation of a sigma bond. If we have a look at oxygen, one of their p orbital will overlap head-on, leading to the formation of sigma bond. The another p orbital will overlap sideways, leading to the formation of a pi bond. Then we saw the differences between sigma and pi bond. These are the differences mainly between sigma and pi. Now we'll move on to the second type of hybridization. That is hybridization involving all, that is hybridization which does not involve all unpaired electron. The first hybridization we did was involving all unpaired electron. In the second hybridization, it may happen that some of the unpaired electron will not take part in hybridization. So we'll see to that. So the second type of hybridization, we'll see, that is hybridization in which it is not mandatory for all unpaired electrons to take part. So it is not mandatory for all unpaired electrons to take part. Some of them they can undergo hybridization, some of them they cannot undergo hybridization. The only thing is the electrons which are undergoing hybridization will always form sigma bond, whereas the electrons which are not undergoing hybridization will form pi bond. So here I am going to teach you the difference between alkene and alkyne. My dear students, you all already know that in alkanes, carbon is always in sp3 hybridization. This we did in the last class. I'll show you. When we were doing hybridization, I taught you sp3. So in sp3 you can see that it is tetrahedral. Here I showed you this structure. This is the tetrahedral structure of CH4. So whenever you have alkane, I'll add one more example into this. This here you have is methane, CH4. Suppose you have C2H6, ethane molecule. We bend this molecule. If this molecule is bended in such a way, suppose I am rotating this molecule in clockwise direction. Then here I have carbon. This is the bond with the hydrogen. 1, 2, 3. 3 bonds here. Now suppose another carbon atom I have got here. That carbon atom is forming bond with this bond, and that is also in a tetrahedral structure. So you will see this is the molecule of C2H6. So this is how all alkanes are. In alkanes, the carbon is sp3 hybridized. In alkanes, the carbon is always sp3 hybridized, and they are always tetrahedral. So if you draw it like this, you will see a tetrahedron. Likewise, for the second carbon also, you will have a tetrahedron like this. So this is another tetrahedron you have got. So in alkanes, carbon is always sp3 hybridized and the symmetry is always tetrahedral. No matter whether you are talking about methane, ethane, propane, butane, pentane, hexane, anything. Now today we'll see alkenes and alkynes. So for that I'll give you example of say ethene. So we'll see first hybridization, that is for ethene. Ethene is CH2 double bond CH2. We'll see how this compound is formed. Well, carbon again has got 2 electron in the S subshell. Carbon has got 2 electron in the P subshell. As I taught you earlier, one of the electron from S will jump to P. That will lead to the formation of 4 unpaired electron. But in hybridization, only these 3 electrons are taking part. That's why the hybridization is sp2. 1 of S and 2 of P. If 3 electrons they are undergoing hybridization, they lead to the formation of 3 hybrid orbitals. And as you already know, that shape of sp2 is always trigonal planar. So if I have got a carbon here, this is one of the hybrid orbital. Here I have second hybrid orbital. Here I have third hybrid orbital. And all these 3 hybrid orbitals, they have 1 electron each. Likewise, if I talk about another carbon, 1 hybrid orbital and with unpaired electron, second hybrid orbital with unpaired electron, third hybrid orbital with unpaired electron. These unpaired electrons are going to overlap with hydrogen. So here you have a carbon hydrogen bond. Here also you have a carbon hydrogen bond. Here you will have a carbon hydrogen bond. In both these carbon, this is the electron which has not undergone hybridization. If this electron has not undergone hybridization, we'll draw it completely. Now suppose this is the p orbital of one of the carbon atom. This is not hybrid, this is complete p orbital. Here I have another p orbital of the second carbon atom. These 2 p orbitals will overlap sideways and will lead to the formation of a pi bond. So in alkenes, we have double bond, that is carbon and hydrogen, CH2, double bond CH2. And out of these 2 bonds, one of the bond is sigma and the another one is pi. Sigma pi I already taught you that sigma is formed by head-on overlapping. So you can see here, this is the sigma bond. This is the sigma bond between 2 carbon atoms. And pi bond is always formed by sideways overlapping. So when 2 carbon atoms, they are forming an alkene, they are in sp2 hybridization. That means their 3 orbitals are undergoing hybridization. That will lead to the formation of 3 resulting hybrid orbitals. The shape will be trigonal planar. Between carbon-carbon atom, you will have a sigma bond. But the p orbital which has not undergone hybridization, the unpaired electron which is present in p has not undergone hybridization, that will overlap sideways with the p of another carbon atom, leading to the formation of pi. So this is how alkenes they are. Now we'll see alkynes. That is ethyne. Alkyne, I'll show you ethyne. In alkenes, the hybridization is, as I told you, sp2. In alkynes, the hybridization is sp. Compound is CH, triple bond CH. We'll see how it is formed. Again, carbon has got 2 electron in S. Out of that, one has jumped to P. In P, it has got 2 electron. One of the electron has jumped from S to P, leading to the formation of 4 unpaired electron. But these 4 unpaired electron will not undergo hybridization. Only 2 will undergo hybridization. That is one of S and one of P. That's why the hybridization is sp. The very first hybridization which you did was sp. And I think you could remember that sp is always linear. So if we have a look at the structure, suppose this is the carbon atom. This is one of the hybrid orbital. Here you have the second hybrid orbital. One unpaired electron, another unpaired electron. Another carbon atom, one hybrid orbital, second hybrid orbital. This unpaired electron will overlap with hydrogen, leading to the formation of a sigma bond. So you'll have a sigma bond. Now what about these 2 electrons? We'll see to that. Suppose this is one of the P of one carbon atom and this is the second P of another carbon atom. They will overlap sideways. they will overlap sideways to form a pi bond. What about the second one? You have another P also. Now suppose this is the second P of one of the carbon atom and this is the second P of another carbon atom. These P, they will also overlap sideways. So they will also lead to the formation of two pi bond. They'll also lead to the formation of second pi bond. That means in alkynes we'll have two pi bond. One pi bond is represented by the red color, the another pi bond is represented by the green color. So between two carbon atom, if I have a look at the two carbon atoms, this is one of the carbon atom attached to hydrogen, you'll have a triple bond, then hydrogen. So between these two carbon atom, one of the bond is sigma and the two bonds, they are pi. So if someone asks you what's the difference between alkane, alkene and alkyne, you'll say that in alkanes carbon is sp3 hybridized, in alkene it is sp2 hybridized, in alkyne it is sp hybridized. That's why alkanes have a tetrahedral structure. Alkenes, they have a trigonal planar structure, and alkynes, they have a linear structure. The molecule is in the line, in a single line. That's why alkynes, they are linear. This is all about the second type of hybridization. Now we'll move on to the third type of hybridization. After that, we'll do a recapitulation of that. The third type of hybridization is in which paired electrons can take part. So although the paired electrons can take part in hybridization, but they will not take part in chemical bonding. This is what we learned in valence bond theory. Only unpaired electrons they take part in chemical bonding. In this, I'll give you two examples. First example I'm giving you is that of NH3. Nitrogen has got 2 electrons in the S and nitrogen has got 3 electrons in the P. It does not have a D subshell. So S electron will not undergo unpairing or they will not get unpaired. So as such they will undergo hybridization. Hybridization is sp3. That is 1 of S and 3 of P are undergoing hybridization. I taught you one thing that if 4 orbitals are undergoing hybridization, they will lead to the formation of 4 hybrid orbitals. And the symmetry of sp3 is always tetrahedral as in the case of alkanes. So here nitrogen is this, 1 of the hybrid orbital, second hybrid orbital, third hybrid orbital and fourth hybrid orbital, tetrahedral symmetry. Out of these 4, 1 will have paired electron, the rest 3 will have unpaired electron. They will overlap with hydrogen, leading to the formation of 3 bonds. So this is what it is. You can see it like this, nitrogen with a lone pair of electrons. This is NH bond, NH bond, NH bond. Dear students, normal tetrahedral angle as I told you is nearly of 109 degrees. But here you got a lone pair of electrons that will give repulsion to the bond pair. That's why here in this case in ammonia the angle is not normal tetrahedral angle. In fact it is lesser than that and it is nearly equal to 107 degrees. So here you can say that the bond angle is nearly equal to 107 degrees. If you combine these hydrogen atoms, you will see a shape that is pyramidal. Because lone pair is never considered in shape. That's why we can say that the symmetry is pyramidal. So ammonia has got a pyramidal symmetry with a lone pair of electron on nitrogen atom. And the bond angle is lesser than normal tetrahedral angle of 109 degrees. Second molecule which I am going to tell you, and this is the last one in the hybridization, is that of H2O. Again, if we have a look at oxygen, oxygen has got 2 electrons in the S. Oxygen has got 4 electrons in the P. So you have 1, 2, 3, 4. It does not have a weakened D subshell, so electron will not undergo unpairing and it will undergo hybridization as such. That's why the hybridization is sp3. If 4 orbitals are undergoing hybridization, they will lead to the formation of 4 hybrid orbitals. So here you have oxygen, 1 of the hybrid orbital, second hybrid orbital, third hybrid orbital and fourth hybrid orbital. You'll have paired electrons, unpaired electron, unpaired electron. The unpaired electron will overlap with hydrogen, leading to the formation of sigma bond. Here also you can see it from this electronic configuration: paired electron, unpaired electron, unpaired electron. Well, for water I can draw it like this: oxygen, paired electron, then paired electron, then bond with hydrogen, then bond with hydrogen. Unlike ammonia, in water we have two lone pair. That means here the repulsion is stronger, it is more. If the repulsion is more, that means the bond angle is still lesser than 107 degrees. It is nearly equal to 104 degrees. So, bond angle in both ammonia and water is lesser than that of normal tetra at an angle of 109 degrees. In ammonia, it is 107 degree, whereas in water, it is nearly 104 degrees. Since lone pair is never considered in the shape, that's why we can say that the shape here is bent or V-shaped molecule. So this is how water molecule it looks, and this is all about hybridization. We divided hybridization into three parts, and we have done that. The first one was the hybridization in which all unpaired electrons take part. In that I taught you sp hybridization, then sp2, then sp3, then sp3d1 in PCl5, then sp3d2 in SF6, then sp3d3 in IF7. After that, we talked about sigma and pi bond. By head-on overlapping, you have sigma bond. By sideways overlapping, you have pi bond. Sigma bond is stronger, pi bond is weaker. After that, we talked about hybridization in which it is not necessary for all unpaired electrons to take part. But the electrons which will take part in hybridization will form sigma bond, and those which will not take part in hybridization will form pi bond. Next is hybridization in which even paired electrons can take part. So although these paired electrons can take part in hybridization, but they will not take part in chemical bonding. I taught you two examples, that is of ammonia and water. And we'll do only this in today's session. In the next session, I'll be taking dipole moment, resonance, and drawbacks of VBT. So please do watch that video also, and kindly go through all these things which I have taught you today. Do questions, and in case you have any doubt, you please come back to me, send me a message, I'll send you the reply. Thank you very much. Thanks for watching, and please do subscribe my channel. Thanks a lot.